This is the Amp Hour Podcast, recorded February 10th, 2015. Episode 236. Verrucose, Vehicle, Vitilitigation.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Hello, nerd.
Nothing. We've got nothing to talk about. That's the whole show, folks.
All right.
Thanks for joining us. Yep. Oh,
I don't know. I'm sitting in my basement like usual, recording videos and freezing my ass off and working on a search engine and yeah.
Living the dream. Living the dream.
Yeah, living the dream, man. Yeah.
I'm living the dream, walking to work.
Yeah. Oh yeah. Yes. So Dave is without vehicle.
I am carless. Yes. I am transportless.
Before we get into that thing, I'd like to mention that I am consistently amazed when my car. I know that you're in a warm climate, but like I have to just give a shout out to automotive engineers and like the fact that cars turn on every time in the cold. Like I think probably like battery engineers, like those, those like cold crank, like the super.
You're right.
Just the fact that it works in the cold. Yep. I mean, I get some of the physics of it, but it's just like, damn, like that is unbelievable. And when I'm that cold, I'm really thankful that it works. So. Thanks, guys.
My car, a German Holden Vectra, came with a battery warmer cover. It's like,
oh,
what
really?
the hell? Yeah, first thing I did when I bought the new car was rip off the battery warmer cover. It's like, what the hell?
Yeah, my car doesn't have. I know a lot of Alaskan, like people up in Alaska,
right,
they have they run to the store, they plug their car in to keep it warm, that kind of thing.
Okay.
But that's more for the oil, I think, just to keep the oil viscous enough so that it actually turns over. We shouldn't stray too far into the mechanical realm.
No,
we know how that's gone.
We're going to get taken to task.
Yeah.
Anyway,
what's
I took my car. It's always been a heap of crap, right? And I basically driving it into the ground, right? That was my plan.
Which is good.
Yeah.
Good. Yep.
And so I was going up to the mountains on the weekend, right? Big trip, So I thought, I better have the car serviced. Haven't had it serviced in a long time. So I went to get it serviced, put it in, and they called me up and they went, dude, this thing's a death trap. You want to know what's wrong with it? Everything. So the list is as long as my arm,
oh my
the things
God.
that were wrong with it. Yeah, it's just, It was unsafe.
The benefits of a short commute, it's a lower likelihood of
death, yes.
Yeah, statistics were on your side just simply because of time spent in car.
So it was ready to do a Bluesmobile. If you've seen the the end scene in the Blues Brothers where the car, just falls apart. It was like that. Anyway. Even if it was working, it was like a $2,000 car, at best.
Yeah. Oh,
and just to get it safe again, let alone make it reliable, was like at least $1,000. So, it's just pouring money down a hole, basically. So, yep.
Yeah, yep.
And the wife won't let me drive it. Yeah, so I'm now, It was great when we didn't know,
Ignorance is bliss.
Yeah,
definitely.
That's right.
So I think the important question here, though, and the question everybody's asking or about to ask, what's next? We're talking a Tesla here, right? We're saying Tesla is the way to go. You're going to have one in your garage.
Oh, yeah. Hang on. I'll just pull out that spare $110,000. Yeah, here we go. There's the change. I've got it. Okay. There's $1. Good. I just need, maybe I can do a Kickstarter campaign to raise the $109,999.
Bigger currency and coins these days out in Australia, huh? I only heard like a couple coins there.
So, I happen to have one coin in my pocket. So I'm $1 towards the $110,000 it costs for a Tesla here. So,
okay, well.
Yep, accepting donations now, folks.
Give till it hurts, folks. Dave needs a car to drive 2 minutes to work.
But yes, it will be an electric car. We have decided, we think, It will be an electric car. And unfortunately, in this country, the only choice is the Mitsubishi my EV or Miev, however you want to pronounce it.
Yeah, the one that you did. You got to ride one of those, right?
Yep. I got to ride in one, and
yeah,
it's like, and I thought, okay, look, I'll build my own. That'll make for some cool videos, right? You know,
it's a tax write-off.
Yeah, exactly. It's a complete tax write-off, right?
Yeah.
Whereas buying a normal car isn't. Whereas building one would be, right? I check with my accountant. Yes.
Right.
So yeah, and so yeah, but
I think you should just soup up the C1, man. What about that?
the C5, yeah, the Sinclair C5.
Oh, sorry. Yeah, Sinclair C5.
Sinclair C5. Yeah.
After you get through with it, it'll be a C1.
Anyway, it turns out
plastic wheels.
Yes, I talked to all the experts in building your own electric car, and they all say buy a Mitsubishi MyEV. It's cheaper and better than anything you can build yourself, because it's really expensive to build your own EV.
Right.
And to actually make it good, to give it a real monster battery pack and make it, really good.
Right.
So,
well, and there's the whole mechanical side, like we mentioned at the top of the show. That's so bad.
Yep. They all said just go out and buy a 5-year-old my EV and just be done with it. So,
nice. Yeah, I mean, you'll still be able to do cool battery pack experiments, stuff like that.
Yeah, things like that. Data login and stuff like that. I've got, and
yeah. Well, I always wonder about like the thing I always wonder about with the Prius and a lot of those cars out there. Like, I mean, battery packs they start to have issues over time, and it seems like that's such a huge chunk of the cost of a vehicle that isn't that like kind of a risk?
It is a risk, but from the people who've owned these things, I've been talking to owners. And they say, yeah, look, they've had one for 5 years and they haven't noticed any range drop yet.
Oh,
so,
okay.
Apparently they do pretty well.
Any word on the actual what the range is too? Because I know, you have a short commute now too.
The range is 150 k's max.
Oh, that's not bad at all.
It's okay, but it wouldn't get me up to a canyon and back. It wouldn't get me to the nearest canyon and back. So it's of limited practical use there. But
what about around the country? Are there chargers around the country or no?
No, there's basically nothing here. But you can charge it from a regular power point. So all you got to do is find a regular power point, right? Or it's slow, of course. It's slow.
Right, but you guys are 240, so you get added benefit. I mean, I guess you have lower current on the
it's the same amount of power. It's all about the power. Power transfer.
Well, yeah, it's all about the power, but then it's about the. I mean, the chargers as well. They have higher current drive as well, but
it's higher power delivery. So, yeah.
Okay, well that's but you don't. So, but there's no charging stations around the country or anything like that.
I think there's very few, not to make it, worthwhile actually doing, actually using them. So, it's a basically around the town type car,
Okay.
So
that's something still. I mean, that's interesting.
Yeah. The only annoying thing is that here in the EV blog corporate towers, down in the underground basement car park, there's not a single power point.
Oh, really?
Not a single power point.
Run a line out from your your dungeon space, basically.
Well, there is. At my bunker. My bunker is an underground thing, and there are power points there. So technically,
it's a different building, though, right?
Yeah, it's a different building. So technically, I could drive my car there, park it in somebody's spot if they're not there. It's a bit rude. But I could, in theory, do that. So,
I'm very curious about this. I mean, I think that I'm really glad that it is coming down to the affordable range and stuff like that. That people can actually get these cars because I think it's just kind of an exposure thing.
Well, it is a 5-year-old secondhand car that I'm considering.
But I'm
getting,
just saying that the fact that there are 5-year-old cars is necessary to have that in the market. It's just
true.
a matter of over time.
Yep.
Not everyone's going to be able to afford a new car. Just in terms of accessibility, right? You're doing it for economic reasons, but a lot of people just won't be able to afford even the Chevy Volt is $35,000, I think. It's
which
just
is about 50,000 here. It's about 50.
Oh, really? Okay.
Yeah.
And I mean, it's I think it's even smaller range than that that you're talking about.
Yeah, but it's got the backup petrol engine. So it's got unlimited
right.
range. That's the advantage of the Volt, the Holden Volt, so Chevy Volt. So
Gotcha. Okay.
yeah, I'd love to have one of those, but it's $50,000, right?
Right. Yeah.
So
Interesting. Yep. Well, anyways, there was a video that I saw today that I posted on the subreddit. It's called Empower, and like a smart grid, it kind of offloads. I mean, this idea has been around for a while. It offloads power, and it can basically the whole promise of the smart grid, basically pulling down power when it's cheap, pushing it back to the grid when it's expensive, so that you can barter for that kind of thing. And then basically the grid is then paying you for storage. Basically,
right?
That's the idea. And I think about that though, and I think about that with cars. I don't know. Like, I know it's they even talk about it in the video of like, oh well, we watch your habits and blah 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 blah. But it's like, if I showed up and my car wasn't fully charged, I would feel not great.
Right? Yeah.
I mean, I get neurotic about a cell phone if it's my car.
Exactly.
I feel I obviously don't know, right? I don't have a electric car, but yeah, I mean that would really bug me.
I expect it to be quite a paranoid feeling having this, knowing that I can't just fill it up in 5 minutes, right?
Right.
On every corner.
Yeah, it'd be interesting if like eventually, like, I don't know, you guys don't have like Auto Club or AAA, maybe it's called something different there probably. But like if eventually they're just showing up with like a huge battery pack
right.
and it's just like juicing you up, like that's just weird.
Well, I
don't know.
actually haven't looked into this or asked, but I wonder if it's possible to keep like a petrol generator in the back, like a 10 amp, petrol powered generator.
Well, yeah, if you remember when Bob Simpson was on the show, he talked about they were developing that. I mean, he was talking about it actually being built in.
Right,
but remember he said he was talking about a new 2-stroke motor, and it was basically to drive. It was a 2-stroke motor, but it was to drive a generator that charged the batteries.
Yes.
So we might have to check in with him now, but basically that was the idea, is that it's an all electric, but then there is some kind of backup there because you're going to run into times where you can only get,
of course,
energy from good old hydrocarbons. So
that's the price you pay for having an EV now. I mean, the infrastructure.
It's exceedingly convenient to have an explosive liquid that drives like just the power. I mean, there's the power density of gas.
Yes,
like
exactly.
There is, you don't. It's hard, man. You don't get away from that really easily. And
I know.
Batteries are not even close.
Yep. So
I don't know.
But still, if you wanted to carry around like a full tank's worth, like that's a lot. That's a lot of petrol. So, yes, they are high power density, but your car, might drive 500 kilometres, but it needs 50 litres of petrol to do it. 50 litres isn't a small amount.
Sorry, my brain is like,
I know.
Do these conversions. I'm like,
metric, I can't handle
damn it.
I can't handle it. Anyway, you do understand what I'm talking about, right? Is
3.8 liters to a gallon? Is that right?
I have no idea. I never need to work in gallons ever.
I know. Oh, God, I hate my imperial
right.
brain.
It sounds right.
Darn you, America.
See, gallons is one of those imperial units. Yeah, we simply never. We have zero need for. Because nobody else, there's no need for it. Whereas, feet, inches, all that sort of, miles, yes, I can do that. I know the conversion off the top of my head. Pounds, yes. Inches, yes. Yeah. But not gallons.
It's all about. It's all, for me at least. I mean, I have to do these conversions on the fly in my head, but it's all about what I have seen on packaging and stuff. Like, it's always like I have to picture the thing. So do the distance conversion, I think, okay, I've run a 10K before. I know that's 6.2 miles.
Right.
To do the weight conversion, I know that a 5 pound plate at the gym is 2.2 kilograms. Right. For this, it's actually gallons of milk. Right, and I think I've seen 3.8, and it's actually 3.785 liters in a gallon. So dumb.
No, but that's
stupid brain.
No, that's the way it works. I mean, that's fine. There's nothing wrong with that at all.
So I saw someone tweet about this during the Super Bowl, which just happened, and they said, I bet if football switched over to metric.
Yeah.
People would be using metric by morning.
Right. Oh, goodness.
God damn it.
Gallons. Damn it.
Yeah. I know, gallons.
Anyway, you know what I'm saying. Like, it's not magic. It's not like plutonium, that has,
Oh, right. It's not like you're dropping a pebble into a, a chamber.
Yeah.
It's not Mr. Fusion,
no, it's
right?
not Mr. Fusion.
Not yet. Yeah, I know, and it's frustrating. And like, there's another article I found about the Technology Review did one about battery technology, right? I mean, this is the limiting factor. We've talked about it on here before. It's same for grid storage. It's same for transportation. And and to be completely blunt, energy generation and storage, that's basically Iron Man's superpower, right? I know that's kind of going nerdy
but completely rocket science. I mean, that article is bang on, right? The article is basically saying that it's practically impossible for these startups, all these battery startups, to actually succeed, because it's big engineering, it's big science, it's big physics,
exactly. You need a lab with lots of smart people doing very controlled, high energy experiments over time, and it's not like there's leaps and bounds. It's like
and that's what they said. Most of the progress,
we're running into physics here, folks.
Most of the progress in real battery technology, i.e., the stuff we're using today, has come from small incremental improvements in existing technology. So any company who comes along, a startup comes along, and claims, "We've got this fantastic new technology." Yeah, e-store, right? This fantastic new technology. You just go, well, yeah, bullshit. There's 99.9% chance you're going to fail. Because
we'll believe it when we see it.
Yeah, it's. I hate to say it, but yeah, they're right. I mean, there's just no evidence that, there's countless, battery technology startups out there, and they've all failed because
right.
Yeah.
Well, and ultimately, I think, Tesla's doing it right. It's just like they're just brute forcing. They're saying, here's the best we can do. Let's see what we can do with it. They're sourcing lots of batteries. They're building a big plant.
And they teamed up with Panasonic. They teamed up with the world leader in batteries, Panasonic, right? And they didn't do it themselves. They didn't buy some startup and go, yay, we're going to put this whiz-bang technology in our Tesla. They would have failed.
Right, right. Yep. Yeah, that is frustrating sometimes when you see that. You see... it's exciting, right? The idea of a startup is exciting,
of course,
because they can do some interesting things, think different ways, right? That is very exciting. But like certain things are done for a reason, right? I mean, like with the hard science stuff like that, it's like, man. I still
fully support all these startups trying to do this, but just be real.
Right.
If you're going to invest in it, just be realistic. That's all.
Oh, well, yeah. If you're going to invest, right. Yeah, well, and I think the claims as well, too. It's like, don't believe one test in an isolated circumstance, right?
Because that's what this article linked to.
Our dielectric constant is super high in our supercapacitor. Who gives a crap? Show me it's storing, many, many kilowatt hours of power, of energy, rather, and delivering it consistently over an entire batch of stuff. Like, but there's your proof, right?
That's what this article was saying, right? Because they gave the example, GM, right? They bought this battery startup thinking it'd make them the world leaders in, battery EV technology, right? And then once they bought the company, they tried to recreate their technology and found, we can't recreate it. It was a fluke, is the word they used. It was
feels bad, man. Feels real bad.
Sorry about that, guys. It worked in the lab.
Yeah, can you imagine being the guy who signed on the line? Like the one who's like, we're ready to pay all this money for you. Wait, what? What are the results? I'm retiring. I forgot to tell you.
Oops. Oh, dear. Yeah, so they failed. So they're behind the 8 ball again.
Now, you brought up an interesting thing. You told me about an interesting thing before the show, though. So we're talking about hard science. We're talking about, don't try and fight the power. And yet, Dave brought up a very interesting thing.
Somebody was able to do it. Somebody.
In a weird way, too.
Yeah, a fellow video blogger, Thunderfoot, I know a lot of people don't like Thunderfoot for his outspoken nature. Well, too bad. I do. I think he's awesome, and I do back him. Anyway, he's a fellow He's a fellow YouTuber. He does science among other things, which we won't mention. But anyway, he does science videos and stuff, right? And he's a PhD chemist. He's actually a quite highly renowned chemist. You know, he has like 100 papers published and stuff like that, right? So he is actually a research chemist. But basically, his full-time gig these days is making YouTube videos. And anyway, a couple of years back, he did this YouTube video, the old, thing, sodium explodes in water, right? And as I believe the story went, right, he just did that for some fun, right? He thought, oh, yeah, that'd make a cool video. I've got this little cheap-ass high-speed camera, right? Let's just film some, sodium blowing up in water. Everyone does that, right? You've probably done it in your science class or whatever. It's one of those, classic, science demos, right?
It's fun.
Yeah,
it's
it's
loud,
fun and loud, and it's not too dangerous.
It makes science intriguing, if not...
Exactly, right? And
not a lot of scientific method with dropping a thing into water, but it's fun to watch. So, and apparently, right, everyone knows, right? This has been a well-known phenomenon for, 100 years or something, right? Everyone knows why. Everyone knows the chemical reaction when sodium hits water, blah, 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 and why it explodes, right? It's a... it's a given that we know how this works in science. And anyway, so he filmed this thing in high speed with the camera. It was only a couple hundred frames per second, but he noticed something funny in there, that it didn't quite match up. What he was seeing on the video didn't quite match up to the traditional theory of the chemical reaction and how, the chemical sodium hits water and it produces hydrogen, blah, blah, blah. I don't know. I'm not into the science of that. But anyway, so something about bonds. I don't know.
Anyway, there's a chemical reaction, right?
High energy bonds,
and that's what forms the and that's what causes the explosion. It's a chemical reaction. And he went, well, that doesn't feel right. His gut feel, it just didn't look right. So he did some further investigation, and he did some more videos on it, and he, look, I think something funny's happening here. It doesn't add up. And he went to talk to experts on this sort of thing, even though he's a chemist, still Winston, and they all said, no, it's well known, it's well proven, blah, 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 it's a chemical reaction. And he went, well, screw everyone. I think there's something to this. And he went to... He went overseas, I believe. I can't remember the country. Anyway, he formed a research team to actually investigate this, right? And over the last 2 years, 4 years, I think it might have even been. Anyway, they've been investigating this, and finally, they've come to they've released their results and had it published, of course, in the top peer review journal. And bingo, it's not a chemical reaction. He's turned the entire field of chemistry on its head. It is a Coulombic charge reaction, which means it's actually an electrical...
Crazy.
Yeah, I know. It's crazy. And it generates like 1,000 times, in theory, 1,000 times more current than a bolt of lightning. It is the highest current in all of nature. And these Coulombic charges are known. It's not like he discovered, these Coulombic charges. But the fact that it's not a chemical reaction and it's an electrical Coulombic charge reaction that's actually happening here. Anyway, this made huge headlines all around the world in all science blogs and everything else. It made all major news stories that, scientists have discovered that, yes, they've turned it all on its head. And it's fantastic. And it started from a YouTube video. This is what I love about it.
I know that, and as I said before, I know that Dave wants to be like, the YouTubers change the world, and it's true. It is true in this case.
Yeah.
I don't know what is a Coulombic charge reaction though. What does that mean?
Don't ask me either. Anyway,
okay.
It's a...
So we gotta watch the video or read.
There you have to know the science. Look, I'll admit I don't know the science off the top of my head. Anyway, it's a charge reaction. It's like repulsive electron repulsion, something like that.
Okay.
Yeah,
cool,
I'm embarrassing myself here. I should have, If I knew I was going to talk about it on here, I probably would have researched it better. But anyway, it's not a chemical reaction. That's the whole point, right? And everyone thought it was,
Yeah.
That was like as fundamental as anything, dropping sodium in water as, a chemical reaction. Anyway, and also as a spin-off from this, right, he also discovered that if you put a tiny, like 5 ppm part of hexachlorine or something, I don't know the actual chemical. Anyway, if you put like 5 ppms of this hexachlorine stuff in the water, it stops the reaction. It totally stops it. It actually it doesn't allow the charges to take place and build up and cause the explosion. And the reason why this is important is because this is a huge industrial safety thing, right? There's lots of chemical and metal manufacturing plants, right? They have massive explosions that destroy their entire factories because some of the hot metal hit water, hit the cooling water tanks, and people die every year as a result of these sort of things. But they've discovered that, if you put just a tiny amount of this chemical in there, it actually stops the charges from, escalating and exploding.
Yeah.
So it's great.
Yeah, the energy release. Yeah, that's really cool.
And the reason was able to do this research full time is because people like me backed him. So he had the financial thing to actually work on it.
You said that he thanked all the backers in his Nature paper.
He thanked all the backers in his Nature paper. I think it's the first time ever in a scientific paper somebody has thanked crowdfunding backers. So that's
awesome.
It's just
hopefully not the last though. That's,
no, that is just awesome.
I don't think that's common because I think that a lot of the stuff that gets published normally in Nature probably wouldn't be crowdfunded, but
exactly.
That is interesting because of the educational aspect to it.
Oh, totally.
The video making.
Yep.
Yeah.
Yeah. And of course, it could have amounted to nothing, right? He could have, you could almost say he got lucky, right? But
no, I could say that that's research, right?
Well,
research has lots of dead ends, right?
Yeah, well, it could have been a dead end. That's the thing, right? He could have thought, something weird's going on here, and he could have done his 2-year investigation and found, no, it really is a chemical reaction, So, but
I believe someone I know says, "I hope your project doesn't work the first time," and that's basically what that would be, right? So, I think that's what science is. You're going and you're verifying and. Mm-hmm. Then I think that the next step there, though, is peer reviewing, right? It has to be replicated by other people. It has to be accepted. Other people have to write about it, that kind of thing as well.
Yep.
So,
but it's awesome.
Yeah, so it's not over yet, but it is very interesting.
Yeah, I think it's not luck because, very early on in their research, I'm sure it would have been obvious, we're onto something here. We're onto something. And they got a $100,000 high-speed camera to actually shoot the charge, to actually photograph it all and all that sort of jazz. And they develop physical rigs to, drop it in a controlled way and all that sort of stuff, so that they could actually, And it's just terrific.
Yeah,
right?
So that's not usable charge though, right? It's just a quick release of that charge.
Yeah, a lot of people on the forum have been talking about this. Can you actually measure? Because it's the highest amount of current generated in all of nature. Right, so people are, suddenly started thinking, can we harness this, or can we actually at least measure it? If you whacked a coil around the tube, could you actually measure the magnetic field from it, right? And something like that, right? That'd also be cool. And
the biggest shunt resistor ever.
But that'd be awesome, right? If you could actually measure the magnetic field coming out of it. I don't know. Everyone's with more, chemical, more, physics knowledge than me are talking about it on the forum, which isn't hard, by the way, to have more physics knowledge.
That is interesting that you have to have some kind of way to measure it to actually verify, right? To know what that is.
But everyone's saying, I think the consensus at the moment is that no, the charges would be in random directions, so they'd cancel each other out. And they'd be so quick that you wouldn't be able to, it'd be, down at the femtosecond level or something. I don't know, something like that.
Right. Well, the impulse, of the, it's delivering power so quickly that it's that's part of the explosion part.
Yeah, it's exactly.
Yeah.
So anyway,
that's really cool though.
And
to take that back to the battery thing, that's hopeful, right? The fact that there is, yeah, you're going to have to prove people wrong if you're going to have to put the work in, but you can prove other stuff that, there are other ways of doing things or that other things are understood poorly, and that kind of usually causes breakthroughs. So
And
that's good.
You watch in 6 months' time, we'll be embarrassed and have to admit, yep, a startup battery technology actually worked, and
Great,
you know,
great, and I hope they get rich
is,
as hell.
yeah.
Fine, whatever.
Absolutely.
I mean, because it's the thing, like a lot of these problems too. It's like, prove us wrong. Great. That's like I hope. I
Absolutely.
wanted that for EE Store or any other ones. Like, it's just like this is really necessary for grid parity stuff. For storage power, for electronics, for cars, for transportation in general. Thinking about airplanes and trains and larger vehicles. You're not doing that on lithium ion right now just because of the weight ratio, the weight to power ratio. So, got to have something else.
No. I'm always happy to be proven wrong.
Yes,
which is great.
And you always love proving others wrong too.
Well, as practical engineers, right? That's our job. When people come along with bullshit, right?
Yeah.
Things that don't, match up to practical reality, it's our job to call it out. Right? And,
yes, but I think that, someone may be getting a little grumpier and jumping to conclusion here over the years.
Me? No.
You?
Come on, chip printer, prove me wrong. Go on.
Well, yeah.
Yeah.
Well, no, you're right. That's a prove over time thing, yeah?
Yeah.
One of the things that is not close, but is printing-wise, that Volterra we talked about 2 shows ago. That is now on Kickstarter. It won that hardware battlefield thing at CES.
Right.
But so it's doing well on Kickstarter.
Doing
That's good.
well. Within 24 hours, their goal was 70,000. It's now up to 184. That was within 24
only
hours.
184 days.
Only. Sorry, no, it's up to no. I just refreshed, and it's 185,900, and it's got 29 days to go. And see. This is the thing.
Go ahead.
Right.
Oh. The thing is...
we had a little debate about this on Twitter, right? I think this is fantastic, right? I fully support them. They're a startup. They've been working on this for a couple of years, and it's great. Okay,
yeah,
but...
It's cool. I mean, especially
it's cool,
I really like
right?
the 2 types of ink. That's a cool idea. That's very
right?
cool.
It's cool, and I think that they've implemented it really well. But... it's a solution in need of a problem.
Probably.
Right?
Maybe not.
Maybe not. But it's like the the do-it-yourself pick and place machine. It is such a niche field of need that people want to believe that they have this problem that this thing is going to solve, but unfortunately, it's not. Right? And they claim in the video, right, just press print, right? And yeah, that's technically correct. Just feed your Gerber files in and press print. That's technically correct. What they don't tell you, though, okay, is that you have to redesign your board to fit the technology. It's not like you come up with your new product, right, and it's going to fit in this case. Here you go. You've laid out your double-sided board. It's fantastic. And you can just go press print on this machine. No, it doesn't work. You have to understand the limitations of this thing and actually design your board in a special way to print on this thing, to build your prototype,
true. Yeah,
right?
true,
and then you have to go relay out the whole thing.
Like that. Yep.
No, and the way they do it, you can't. They say you can do double-sided boards, but you can't put components on the other side. You can't lay it out like you would a normal board.
Right. It's going to be a single board, but you can cross-trace. Basically,
you
the idea, I was looking at the video,
yeah.
you can cross-traces, and
which is great.
That's the big thing.
Right?
That actually does
help. Which is fantastic, right? And so technically, yes, it's double-sided, but you can't take your existing design and just print it out on this thing. That's not how it works. I'm sorry.
Right,
it's
but
just,
I don't know if that's really the problem either, though, because I think if people are in a pinch, right? If you're in a pinch, you're going to design for this, right? You are going to design for the tools you have. That makes sense.
Yeah, but if you're in a pinch, you are not going to go lay out a board and fiddle around printing it on this thing. You're just going to go build it. You're going to build it on some prototype boards.
Yeah. Right, that's the ultimate question, right? Is now this becomes an intermediate stage because you do have to redesign it for a different process, right? Maybe they'll have a conversion tool, take take a different
I wouldn't
type.
put any stock in that.
No, I know. I'm just that's total conjecture. But what I'm saying is that that is a different workflow.
Mm-hmm.
But again, all of these things are valid, right? If you're in a pinch, it's very realistic that you might need something like this, right? I mean that
you might,
especially but
I like everything
but the question comes
I've
down
ever
to
done. I can't see where I would bother, even if I had the thing sitting here, right? I can't see why I would bother.
Well, that's what it comes down to is when you're in a pinch, it's how much pain you have, right? Because one of the things they talk about in the video is, yes, you have to wait 2 weeks, but if you have that much pain, you could also pay extra to have an overnight process, stuff like that. So,
or you can just prototype it dead bug style or whatever your preferred method is, right?
Right. So ultimately, I think that's one of the things that they're selling against is that idea of instant stuff and simple iterations and things like that. And that is valid, but it's just a matter of, the trade-offs with, the different process, the cost of materials, all of those things. They're just different trade-offs.
Yep.
So it seems like so far the people are interested in that. So that's good. That's ultimately what's going to be interesting to see is are we seeing quick turnarounds on ideas? And
but look, I'll say right. This is, I think, the best one we've seen. Right, if you do need or you are after something like this, I think this is one of the best ones we've seen. Right, it's great.
Yeah.
Right.
Assuming
it works and it meets
it.
assuming it's it's actually going to happen.
I'm still curious about I did a little bit of math on the current flow of the traces, and it seemed like it was still 40x of copper.
Right. I haven't looked at the 40x. Figures. What are the figures?
I was just doing some
what are the
back of the
here it is.
Back of the envelope. Yeah. And so I was just comparing it against a trace calculator online. And it seemed like it was 40x the now, but a lot of the times that doesn't matter, right? Especially if you're doing like digital stuff, just simpler stuff. So
yep.
So I mean, so what I think about, I honestly think about my past experiences as well, right? So I was kind of going through a similar thing when I was prototyping mechanical stuff, right? Obviously it was terribly drawn. It was in SketchUp, mind you. And I ended up sending it out to just I was going through like the numbers of, I should just buy this decent, $10,000 3D printer, right?
Right.
And then what it came down to was like, I needed that print. I needed that one print, and I was thinking about that, and I was extrapolating that. But literally after that, I mean, on the project I was on, I was iterating. Once that was figured out, it sat there forever, right? I mean, like, especially for that mechanical thing, that just sat there. And so the printer would have sat there as well, and that specifically, in my situation, that would have been looking for a solution then, because, and maybe that drives other innovation, right? Because that's kind of a surplus of, you don't really know what you're going to do with something until it is sitting around,
right,
waiting to be used kind of thing.
Right.
But in my case, it would have been in terms of the cost balance of even paying extra to have it shipped to me quickly, that prototyping tool wasn't useful past the first stage.
Right.
Similarly with electronics, like I had probably, on that exact same project, once the mechanical stuff was figured out, I sent out maybe, 3 or 4 revs of a board, but I was doing so because I was also building and, I was revising stuff, but while I was revising stuff, I was also testing on my current prototypes with, the bodge wires and everything else. And that's, that was just kind of built into the project of, yes, I had to wait, but I had so much other crap to do that, like, that iteration wasn't really there for me. Now, that could just be my style, but that's kind of what I think about.
I think you're right. I mean, just think about it, how many quick turn prototypes can you buy for the $1,400? Or what's the price of this thing?
I think it's $1,800 for the normal version.
Right.
So
see that if you're in a pinch, right, you get a 24 or 48 hour board spun. If you really need a board, right?
Right.
otherwise, like, like they're just showing like fairly simple circuits that you can build up in a few hours on any Vera board or any other, prototyping board, right? I mean, but if you're building something complex, well, would you bother doing it on this? Like, because if it's complex, then it's going to take you days to lay out the board, right? So it's going to take you a day.
4-layer, you might want 6-layer, 8-layer kind of stuff as well, right?
Yeah, it's like, it's just...
Right, so it becomes this corner case, and that's okay, though. Like, but the thing that I think that this is great for, and the same thing for a lot of the other prototyping tools out there, is the learning aspect. Seeing something come to life that quickly is very, very powerful for the turnaround. So, like, if you had this in a classroom, or even like a fab lab or a makerspace, or anything like that, seeing that turnaround is extremely important, because
I agree.
As someone who teaches a course on layout and building electronics, it's frustrating as shit to be like, all right, well, we're doing all this stuff, but don't forget to think about this and 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 this, and then eventually you'll get your board back and it'll still have something messed up, because that's electronics. You know?
Yeah. So okay, But I think the problem is people are buying it, think it's going to solve a problem for them. And I think in most cases it's not. Yeah, I think it's going to be a cool toy for them to play with. Like, I would love one, right? I'd love to have a play with one.
Of course, me too, man.
Right? It's cool. And the other thing is, right, the other interesting thing is that it can do solder paste dispensing as well.
And reflow.
Well, how does it do reflow? Has it got a heated bed in it? Has it?
It does,
or do you put... Right, so it's got a heated bed.
So it's got special glass plates.
But it's not. Like but it's an open. It's an open machine. So you're saying it heats up the bottom of the.
Yeah. It's like a hot plate. I mean, it's effectively just a hot plate.
Right.
But it's controlled, and that works for a lot of stuff. And I mean, they're tempered for the ink that's on board too, right? Because you want to melt the solder, but not the ink that they're laying down.
Right. I thought maybe they've got like a hot air reflow attachment for it, so it goes around and actually selectively hot air reflows.
Oh, that'd be interesting.
Yeah. That's what immediately jumped to my mind was that. Anyway,
it seems like it's the in terms of the dispensers, it's mostly like just a mechanic. It's just like turning a gear in order to dispense. They got like a holder for the paste. They got a holder for the inks.
Right. So
and it's just turning it, because they even talked about in either one of the Reddit threads or somewhere else, so people have been asking about drills for doing, just for through-hole components.
Right.
And they said, no, we don't have that right now. Yep. And probably because that gear, that there's no spindle mechanism yet. Right. Maybe in the future. Yep. But
once again, they've got to be careful not to fall into that trap of trying to be all things to all people. That's... Of course, that is the death call for any product, really, when it tries to do all things.
I have to say, I mean, I was pretty sour on the idea to start with, but as I've seen more stuff with it, I think it's a nicely designed product from what I've seen. So
it looks very nicely designed. Oh yeah, I got no beef with it at all. My only beef with this, and it's not just this, it's all of them, right? Is that I mean, the usage case is. Like, people think, like, they're advertising. That's the thing, right? They're not admitting that. They're advertising. They think this is really a replacement for getting your PCB prototyped. It's not. It's not.
For some people, it might be.
But But it's
not us.
Right. Yeah. I just don't think they've lived in the real world enough. They're so caught up with the idea that they think it applies to everything. And I'm sorry, it doesn't, That's just the way I see it.
Well, that's okay, man. They'll be able to, like we said earlier in the show, they'll just have to prove you wrong.
Yeah, no, that's great. Well,
other people.
Well, and that's the thing, right? They will effectively prove me wrong by having a really successful Kickstarter. I'm sure it will be really successful and people really will buy this thing. But it doesn't mean people are actually using it, like actually fulfilling that dream of using it as a replacement for PCBs. It's like, so
you're right. Yeah, if you see 3 new projects in a row that say prototyped with this thing, I mean, not even that much, but even if you just hear about other things being prototyped with it, then like that's kind of the measure of success.
That could be the vindication. Yep.
Yeah.
Right.
Yeah.
Right.
Well, other people can go and start a different hardware startup and prove you wrong in other ways if you'd like. I don't know if you saw Bolt and Y Combinator have teamed up.
Right.
So that's some big news.
Yeah. Hardware startups are flavor of the month. They really are. And this thing will do well. This thing will do really well.
Oh, yeah. No, the Bolt team's great, too. I mean, I know Chris and Ben and Kate, and they're just really bright people. I met some of the... Actually, when I was in Boston for the hardware startup meetup, or not the hardware startup meetup, sorry, the open source hardware convention, that was... we got to go visit there. And, I mean, they're all doing really cool things, actually.
Right.
So that's good. I think that's a lot more stuff, and basically they're going to have a West Coast presence now. What I wonder about is, so like, now that there is more focus on it, right, there's lots of interest in hardware. We keep hearing about that stuff. Mm-hmm. I can't help but think on the downside, like when hardware goes cold again,
right.
that's actually what I'm worried about, but
right.
I guess we'll get there. I think we still have I think there's still a lot more interest to be had. So
right.
Ride that wave while we can.
Apparently, Volterra got $25K seed funding from Hackcelerator.
Oh, yeah. They're over in Shenzhen. Yeah.
Right.
Yeah.
There you go.
Cool.
Anyway, good on them. Sorry, guys, if you're listening and you think I'm a downer. It's because it's the practical engineer in me, and I think I'm right.
And just never don't design a product for Dave, though. That's a big mistake. I mean, that's the thing. Like, if you're designing for the general, like a more broad audience, you're going to have a bigger marketplace to sell to. So that's good, right? So even if it fits, less, if they can't chase down experts like you, that's sometimes that's okay. That's making power user tools is risky.
The problem thing, I would tell them something they don't want to hear, right? These people don't want to hear that there's not a huge market for this thing, right? They don't want to hear that. They think it's going to change the world, and well, good luck to them, But personally, I can't think of anything more annoying than having to lay out a board specially for this machine just so that I can get a prototype done. I'm just going to not bother. That's me. Maybe some other people are different, but yep.
Well, I think one thing I would do. Have you seen the new Macrofab site? Macrofab.net.
No. Who are Macrofab?
So we've had Andrew on the show before from Circuit Hub. This is a kind of similar service. It's a little bit different in terms of execution, but basically you upload a project. It can do two-sided boards, I think, for now. I tried a 4-layer board. It didn't like that. But basically, you can upload, and then you go through the whole thing. I mean, you go source parts, and basically they'll go and order parts for you. But the cool thing is the different steps. Again, if you go actually click through and everything like that, basically you upload your Gerbers, you upload your BOM, you verify the parts are right, and then the final step that's cool is you actually verify placement of components using part outlines onto the Gerbers. So basically, they're kind of like Mechanical Turk. We talked about Mechanical Turk last night or last week. This is kind of the same thing, except you are the Mechanical Turk now, where you're basically verifying placement, and then I think, but I am not sure, that all of the orders get bundled together like an Oshpark does, where you actually have them all on a single panel.
Right.
And then basically, because the placement data is verified, you also bundle that with the design that's on part of that larger panel, and then basically that drops the overall cost of manufacturing. I'm not sure about the loaders and stuff like that.
Right, yeah.
But the costs
tricky
are very reasonable.
Right.
So there's a demo. If you go to the PCB assembly and then demo, you can actually see one of the projects. Then they actually have all of the different steps you can go through. Mm-hmm. They even allow firmware programming, stuff like that. And so let's see. So single board. This one is the demo that they do is a parallax propeller board, and so for a single board with parts, PCB, and labor, $57 assembled in 15 days, 15 business days.
Very nice.
That's pretty crazy. I mean,
that is insane. Yeah, that's
I mean, that's low. That's a low cost. I mean, so I mean, like
that's just crazy.
So like, yeah,
it's still not as low as just getting your $5 Oshpark board and buying the chips and soldering it yourself.
Yeah, for a single board, I think it's about how it scales then, right? So if you put in 10, it's still the same price per board effectively, and you know, like, so that doesn't really scale as linearly, and to get something that actually places properly and is programmed, and
but you're limited to available parts, right?
Correct. And the other interesting thing that they do is they actually have house components, they call them.
Yeah.
And so if you pick a house component like a resistor or a capacitor, stuff like that, that's actually no charge, just because it's
so
sorry, no, it's not no charge. It's the placement fee is waived, probably because they already have it on. Sorry, I misspoke there. But the placement fee is waived.
Got it.
Whereas if you bring in an outside part, there's a placement fee. So if you optimize for the parts they have in line or have in house, then
you're limited. But if you're like me, every project you do uses parts that you've never used before. You know, it's just.
Well, yeah, that's a bigger question. You know, are you using parts that are what kind of projects are you making? Are you making stuff that's trying out new parts? Are you making stuff that's kind of small variations on open source hardware projects, stuff like that?
Right. Yep.
Yeah.
Yeah. Everyone has their needs.
I work in analog, so it's always different for me too. It's
got it.
But
goodness.
But I think this, I like Circuit Hub as well. Circuit Hub uses I think the Worthington assembly. So for the actual assembly side of things, this one I think Macrofab uses an in-house thing down in Texas. They said so.
Right.
In terms of options, things are like it's looking up for us, right? I mean, in terms of all these things,
we live in a different world.
Oh yeah, man. I mean, like.
Options aren't just looking up; it's an entirely different world.
Oh yeah, and I think the hard part now is just coming up with enough projects in order to. I feel guilty not churning through some of this stuff. It's like
there's
so
almost too much choice for this. Like if I wanted to develop a product. Do something like this, right? I go, oh, geez, what service am I going to use? Like, there's so many, I don't even know. Am I missing out on the best service? I have to go ask the community, which is the best way to do this? And they'll come and say, oh, use this new service and this one and this one. And
it's electronics FOMO, fear of missing out.
Right. Yep. Fear of doing it inefficiently or, more expensive than what you need to. And, I don't know. From the prototype, I'll tell you what. From the PCB prototype side of things, I still reckon that the milling machine, the FR4 milling machine, is still the way to go if you want quick protos. Still think it's the way to go.
Depends how quick we talk. I mean, it's all about how quick and what kind of parts you're using.
Well, it's probably just as quick as this. Well, no, it's probably a bit slower than the silver printer thing, the Volterra thing, maybe. But
yeah, it's
still, But you can do real layouts on it. Get real copper, using your real layout, and you can do double-sided boards. If you route two single-sided ones, you can flip them over and just actually paste them together. What do you mean it blows?
Have you done that before? It's terrible.
In what way is it terrible?
So let's talk about the idea of a VIA, right?
Oh, right.
I mean, like,
that's you have to do your own VIAs. Yeah, you got to do your own VIAs. Yeah,
but I drop tons of VIAs when I'm doing stuff. I'm like, I don't know.
True. No. But if you do need it then and there, right? If you do need it then and there, and you're not willing to wait the 1 or 2 days for a quick turn board,
I think I'm working too slow. That's my problem. I'm just not working fast enough.
Yeah.
I don't need this stuff, but that's fine. That's fine. I'm a relic of the past.
Goodness. Anyway, enough of that. What else have we got? I was going to talk about the speech recognition product.
Your new video. You just released a video right before we started recording.
I did.
That's pretty cool.
Yeah.
So back to breadboards.
Back to breadboards. Yep, the traditional way of doing things.
Yeah.
Yes, and I was actually, it's not a huge breadboard layout, but it took time. I was surprised how long it took. Right, oh shit, I need a 5K6 resistor. Got to go over to the parts drawer and get it and pull one out and actually check it and then trim the leads off because you don't want the gunk on the ends of them from the bandolier, so you got to trim the ends off, right? Because that's a trap for young players, If you would pull one of the, for those who don't know, if you pull a through-hole resistor off one of those bandolier strips that they come in, right, they're held in there with glue. Okay, so you you end up with glue stuck on the end of your leads, and then if you take that resistor and then go stick it straight in your breadboard, congratulations, you've got a layer of bloody glue on your pin, and it may not make contact.
You have a small capacitor,
right? And
dielectric constant of goo.
Big trap for young players. So, actually, that's just given me an interesting video idea. Let me note that down. Let me note that down.
I don't know. I find that I keep coming back to breadboards just because they're convenient, but I don't know, like dead bug, man, dead bug all the way.
Oh yeah, like I don't like soldering if I don't have to. I really like my breadboard.
It's therapeutic. I don't know.
It is, but yeah. I'm so over soldering, I've been doing
soldering
it my whole life.
10 years ago. Yeah. So what is this thing? So this is a chip, the VCP 200.
Yes.
You had actually asked on Twitter for a data sheet, and I was the one who found it.
You were the one who found it because I was too lazy to go and search for 68HC04 instead of 6804.
Right.
Yep.
And then I saw that other people did find you in 6804 on an archive site somewhere. But
right. Okay. I haven't looked.
Yeah,
right.
That can be hard when you don't know the part number. Like that's honestly one of the hardest things when you're like, I know it's a Cortex something, but you don't know what NXP or whoever,
right?
TI or that's like, what is the actual prefix? Because if you even have like the prefix letters and then a couple of the numbers, you can usually get there too. But that's tough.
Anyway, the interesting thing about this, I thought it was always an ASIC chip. Right, I was always of the understanding that this Voice Control Product Inc. is the company, Voice Control Products Inc., which I actually looked. I think they're still a registered company in some way, shape, or form. And so their address is on LinkedIn. So I found them on LinkedIn, and then I looked up the address, and it's a laundromat.
Some dude.
It's a laundromat. So I think they might have like an apartment above the laundromat or something. Anyway, it was really weird. So they might still exist.
A sweet tax write-off over 20 years.
Right. 27 years. So this chip is 27 years old. Yeah, I got it from Tandy/Radio Shack back in 1988. It was so the chip date's from 1988. Yeah. They might be bought by Amazon. Amazon might move into their stores. Anyway.
Oh, yeah, yeah.
Right, that's a bit of news. Anyway, I wanted to see if this 27-year-old chip would still work. And yes. Oh, spoiler. Sorry.
Oh.
Spoiler. Yes. Spoiler.
I'll go back and beep that out. And so it happens. Beep.
And, oh, goodness. Anyway, yes, it did work, and which is cool. And yes, it did understand my Strine exit.
Oh, good.
Yep.
Yeah.
And
it's Tandy, so
and because this is anyway, it's a speaker-independent voice recognition system as opposed to a speaker-trained or whatever the term is, like you train it for your voice,
where you have
right?
like a dragon, what's that called?
Dragon Speak or whatever. Yeah, it's one of those. Yeah, it learns your voice, which is much more accurate. I mean, this thing's only got like 5 commands, right? Like go, stop, forward, back, right? And that sort of thing. So that's how it's able to do speaker independent. And but yeah, it basically works. It's very crude. Like it can't handle normal speech. So if it was sitting here listening to us just talk now, it'd be flashing its lights and going, "Yeah, you just said the word go," even though you didn't.
Yeah,
So,
and I said no, go.
Go.
So, but you said that this is an off the shelf 68 HC04.
It's a mask ROM. I always thought for the last 27 years I thought this was an ASIC, but it's not. It's an off the shelf 6804.
So explain a mask ROM. What does that mean?
It's a microcontroller with the ROM built in, just like you used to now, with the flash micros these days, right? But mask ROM being that they actually...
Kids these days and their flash. Spoiled.
Right. But these
with
days...
With your pager and your 20 volt rails and your... Sorry.
25 volt. Who remembers? Hands up if you remember the 25 volt VPP EEPROM programming voltage.
There
yes,
you go. Yep.
Thank you very much.
You still need high voltages to erase. They just put boost circuits on board. I think.
Yeah, so it runs off your regular 3.3 volt rail, and you don't realise. Yeah. Anyway, where was I? Before you distracted
Mask
me.
ROMs.
Mask ROMs,
Sorry.
yeah. This is the way they used to do it back in the old days, right? The factory could actually, the manufacturer could factory program the ROM information for you. You'd have to order a minimum number, right? But then they would factory program it in, and it's hence mask. They would do like a mask for you, and somehow as part of the chip manufacturing process, they would boom. Right?
Yeah,
something like that.
Now
I
they
don't
can
know
knock
the
out
exact...
with lasers or something.
Or something like that. Yeah. They have some sort of UV on the bare die, and they go through a mask and it sets bits permanently or something. I don't know, something like that. And so it's a really cheap way to get your microcontrollers back then. Otherwise, microcontrollers, they didn't have erasable memories in them, right? Who remembers the first microchip PIC 16C84, right? Which is one of the first ones, right? It was non-erasable. They didn't have E2 PROM technology then, or let alone flash technology, right? So it was an OTP part, a one-time programmable part. So it sort of goes mask, OTP, EEPROM, and then flash. They're kind of like the different levels of technology progression in microcontroller programming, kind of thing. Or
and the
before
EEPROM,
that,
you could also have that. You could have that separate, and then do the little window thing where you'd have the UV
you could
erasable,
do
right?
the UV erasable window, right?
Yeah.
So, or before that, or you use a microprocessor which then uses an external EEPROM.
Yeah, right.
But anyway, so this was a micro. This is a 1988 vintage micro, the 6804, and it's got 1K of memory. So I'm not sure exactly which one they use. There's two variants. One has 1K of memory. One has 1.5K of memory. But either way, it's a pissant amount of memory, right? And they figured out how to do speaker-independent voice recognition inside, like a K or a K and a half of memory. It's unbelievable. And they make claims that, it does spectral analysis and all this sort of stuff and bins them and then compares them, right? It's obviously not doing that in one or 1.5K of memories, right? So they've done all that research on the side, and they've produced tables, right, which are then programmed into the thing. And then I think it's just some sort of state machine that just operates like a state machine, and it compares. So it operates like so it takes the pulse width modulated input, because it doesn't have an analog to digital converter. You actually square up your voice signal that it generates a square wave, which then feeds into the micro. And then,
really?
Yeah. Wow. So, and then obviously they got some whiz-bang algorithms that match up that to your keywords, and then it says, you said go, I'm going to light this output, boom. And that's it. It's an incredibly simple device, but I'm sure there's lots of research that went into the algorithms behind it and everything else.
Wait, so the analog down to a PWM output, it's just...
Sorry, a PWM is not the correct term. It's a squared up version of the analog signal. So what it's got
weird.
is what it's got.
So it's just got a timing circuit then, and it's basically just
it's just got the microphone. There's a high gain amp like times 500, and then there's a comparator to square it up. So your voice gets converted into a square wave that's fed into the micro, and then the micro, how that actually then compares it to the tables and everything else, we don't know.
So weird.
Yeah, I know.
Yeah,
but they were able to do that. It's just, I think it's remarkable. I think it's incredible.
That's still very cool. Yeah. That's very cool.
Yeah. It brings back memories of me trying to squeeze into 1K of memory a video overlay project I did and got published. And that was, I think I squeezed that into 1K of memory, and it was all hand-coded assembler, and I had hook up tables for the text, and for the, so it could put any text and it would actually talk to a keyboard, right? So you'd hook up a PC keyboard to it and talk to the PC keyboard and talk to the special video overlay chip, which overlaid text onto the Power Video. And but that was all in like 1K of memory. It was like all hand code assembly. I think I had like 2 bytes spare or something in the end.
Right. It has been a while since we mentioned on here, but of course people are expecting us to say that someday we will have that 1K code contest.
Oh,
I still haven't done that.
I still would love to do that. I think that'd be neat.
Yeah.
The problem is
get it.
Well, no, every manufacturer still makes a tiny micro with 1K, don't they?
Yeah.
I
mean, you could artificially limit it too. You just have to check it against the code, right?
Yeah.
So,
yeah, exactly.
That is really cool, though. I mean, it's not, that didn't go to any projects or products rather. I'm sure, or if it did, they didn't make it to today. But these are the humble beginnings of talking to your smartphone, right?
Right. And if we did have that project, that contest. This would have won it, right? If you, if you could do speaker independent voice recognition in 1K of memory, holy shit, you win. Congratulations.
Right. Yep.
Totally. So it needs some, sort of out of the box thinking like that. So anyway, I think it's very cool.
So you mentioned erasing chips. I think we should probably bring up the interesting but not really as dramatic as the internet put it, the Raspberry Pi 2 being camera shy.
Right,
I think
of course.
a lot of people have seen this already, but I think it's interesting just because from the packaging side of things, basically it's if you have a Xenon flash, you're impacting the switcher somehow in
You're
order
generating
to make it
a lot of photons.
Soft reset.
If people don't know, somebody discovered that the new Raspberry Pi 2, he took a photo of it with an old-fashioned flash camera, like with a, right?
Yeah, where the hell did he get one of those?
And then it reset, and he didn't think of anything at the time, and he slowly narrowed it down. Yeah, the flash was, causing this board to lock up, right? And I don't think it reset. I think it actually locked up or something. Anyway, and it turns out that it was the switch mode controller chip on there. I don't know what brand, switch mode controller chip. But anyway, they put it on there, I believe, as a bare die. Like, I think it was a flip chip, bare die or something like that. Right? So it was inherently light sensitive, because if it was an encapsulated chip, it wouldn't have happened, right? The light wouldn't have been able to get through the black encapsulation. I mean, this is a very well-known effect, right? Photons affect semiconductors. That's right. This is not new, right? So, of course, if you put a bare die there, even if it's upside down, right, then the light can get under and boom, right? So,
yeah. That's,
right. That's no surprise whatsoever. People seem shocked by this. It's like, nope.
There have been other interesting, like I remember. There's some Tales from the Cubes and a couple other things like that where it's like, where, like we mentioned with the EEPROM, the UV erasable EEPROM, like the tape wasn't on that well enough or the tape wasn't very good.
Yeah. Or they used a white label, a white paper label, which actually lets light through, right? And they wonder why their EEPROM gets erased and their product fails after 6 months.
Yeah.
Oops.
I've had problems on the bench before where I had like a fluorescent lamp above, and I was doing a real sensitive, high impedance input circuit. Yeah. And I don't know what the actual effect was, but basically, like you put your hand over the circuit, and the 60 hertz noise coming from the light basically goes away. It's like, oh, okay, something's going on here. So
that wouldn't have been the light.
I don't know what it was, man, but it was something super sensitive on the input. And
all that analog shit.
Yeah. I don't remember this. I just remember covering it up and being like, okay, well, that's different.
Goodness. Yeah. Anyway, and a lot of people ask, well, I should do a video on this. And I'm going, well, what's there to show? Yeah, it does it. And yeah, it's due to light. This is a well-known industry thing. I mean, it's not a you know. I could do it. Yeah,
it's like
it's a trap for young players.
Photoelectric effect.
It's
like,
obvious, yeah.
type thing, yeah.
Everyone's like, yeah, okay, well, you know, yeah, maybe. But everyone's done a video on it proving that's the issue, you know. So I don't see what value I have to add there. I thought about it, you know. I'd rush out and buy a Raspberry Pi 2, and I'd do. And then I looked, well, and like 10 people had already done a video on it, you know. So,
Yeah.
Sorry, folks.
Could always, you'd have to basically cause some other part to fail with some kind of high energy signal. Leave that to Mike with his X-ray machine, right?
Right. Yep. And you can do it with a laser as well. A laser will do it too, apparently.
Okay.
Yeah.
Well, that's what Shahryar could do, because he just did you see his crazy friggin' video?
Yes, LaCroix invited him to their main headquarters where they design and manufacture and their top of the range 100 gig scopes. And he scored an interview with one of the head designers there.
Yep.
And so
and a tour and a teardown, and it was awesome.
A teardown of the thing, and it's awesome. So, apparently it's within driving distance of his home or something, so he just drove there and went, hey.
Right.
Yeah.
That's
I
nice.
wish.
Yeah.
Yeah, that's what you get for being in the backwater here in Australia, you know.
Yeah, man.
Lack of cool content like that. It's just,
they gotta ship that stuff overseas. That's
a
little less likely with those $1 million scopes. So, yeah, but
I haven't watched the whole video yet, but I love the ending where Shahryar said, and if he was there standing next to the the head guy at LaCroix or whatever, and if you want a demo of this, send them an email and they'll send you a demo unit. And the guy's face just went, no, it's $1 million machine. We're not going to send you a demo. It was hilarious. It was hilarious. Yeah, so this is a $1 million oscilloscope. It costs $1 million.
Yeah.
And
because they're making
it's bleeding edge.
That's what happens when you make tools for super experts, right?
They are made to order. I mean, they don't have these things in stock. If you order one, they will go, okay, we'll start building one. So it's just it's amazing. So and they test them all in house, and it was interesting how they tested their scopes. But they're very expensive high end scopes, right? They don't sell cheap shit. Well, if they do, they just rebadge it from Siglent or whoever. But when you pay $20,000,
the focus of the research is on the high end stuff.
Yeah, it's on the high end stuff. So they can do it all in house. They don't have to go to China. It makes more sense for them to do it locally in house. Because there's no Because when you're selling a $50,000
too.
Oh right, if you're selling a $50,000, $100,000 scope, there's no advantage to going to China. It's just stupid, really.
Yep.
So, anyway, that's it's fantastic. Just the test systems to actually test and calibrate and qualify a 1 gig scope are in themselves.
100 gig, Dave.
100 gig scopes are like bleeding edge, custom developed products. Even more so interesting than the scope itself, perhaps. Right? So
sometimes, a lot of that stuff too, though, like it's a lot of, when you're in school and you're kind of like, well, what the hell am I going to use statistics for?
Right.
Like in terms of like test and measurement. Especially like in the calibration side of things.
Oh yeah.
Tons of stats, just like real world applied statistics, and it's really cool actually. I mean, and you have to do testing. You have to make sure your test stands are okay, like gauge R&R, so that you make sure you're if you have more than one stand, what happens if your stand goes out of cal? You have to do regular calibrations. It's all tied back to a single. You've gone over all this stuff before, but
I come from a production oriented environment, right? Yeah.
Yeah, it's very interesting. It's very tedious, and it's and you got to know your stats. So that's
absolutely. No, it's good stuff. I love it. So it's an excellent video. Check it out. Oh, and and he gets it. Yeah, so they do. So it's like 3 videos in one. It's like it's a theory thing by the head, one of the head designers there. Then it's a teardown of the 100 gig scope, and then it's a factory tour explaining from one of the head of the factory engineering there. So, very cool.
Other links, we're running out of time. Other links I would call out this week. The robotics course. Berkeley's got a robotics course on edX, so that's pretty cool.
But that's news. Why is that newsworthy? Everyone's
into
robots these days. Of course, there's robot courses. Yeah.
It's free. It's from Berkeley. I don't know. It's good.
Okay. All right. Okay. All right. Cool.
What were the other ones?
Ba-ba-ba.
Yeah. The chips that we mentioned last week, the RISC-V cores. We had talked when we talked about the core stuff, the open source cores. Someone did point out that those RISC-V cores have been taped out. So
right.
That's cool.
Okay. Very cool.
What was the other one? There was one other one. Sorry, I'm missing it. I can't find it now.
Schematic tattoos.
Oh, yeah. Yeah, you posted this on Twitter, I think. Yeah,
I found this. I can't remember what I was searching for, but it popped up. I was searching through the images, right? I was searching
like
Google Images, and I don't know.
Okay.
I don't know what I was searching for. And then this just popped up. People who've had schematics tattooed onto them. So we'll link it in. And it's like, well,
I was looking at it. It looked like the tattoos are mostly like people that are into like tube amps and
right.
like
high, yeah.
like they're like these are like class A, for rocker types. Well, maybe not rockers. They don't look that rocking, but
yep.
Yeah, they're cool. They're cool tattoos though, for sure.
Oh well, yeah. You would want it to be
that sort of thing.
Yeah, you would want it to be a kick-ass circuit. Like you wouldn't want it just to be some,
Right. 741.
Right, yeah, exactly.
Maybe, I don't know, something iconic, I guess.
I don't
tattoos
know.
look like they hurt, though. That's
I
the main
know.
thing.
Oh, it looks, screw that.
Yeah.
And it's permanent. Screw that. Also, no.
Right.
No thanks.
Yeah, make sure your schematic's right. I remember the last thing. It's actually not on the list. I was looking for it, but so Analog Aficionados is a dinner that happens once a year in Silicon Valley. I'll be out there. It's actually the 22nd of February, and we did post a link about it, but we never talked about it. So that is in not next Sunday, but the Sunday after.
Cool.
And so that's a good chance to go and meet people interested in analog and people that have been in the industry a long time. So if you're interested, there is a link I'll post as well.
I wonder if the old timers there think, who are all these bloody new young whippersnappers? This was supposed to be just for us,
Yeah, I wonder that too, and I don't know. We'll find out.
Right.
I'll be on the hunt for guests. Let's be
to
completely serious.
Yeah, right. I thought you had been there before.
No, I've talked about it on the show before, but I've actually never gone out there. Remember, actually, on Saturday, it's the 1-year anniversary of me leaving my full-time job.
Wow. So. There you go.
Yeah.
Time flies, dude. I told you.
It feels like it's been like 4 years.
Right.
Who are we kidding here, man?
Yeah,
it feels like it's been forever. So, yeah.
So you're going to hunt for guests.
Oh, hell yeah.
Although I am going to rub it in, right, that you met Mr. LaCroix, speaking of LaCroix.
Oh, yeah.
And you didn't think to ask him on the show?
Yeah. So it's Walter, I think, right? Walter LaCroix. It was very brief. I mean, it was basically like a photo op.
Photo
Hillary,
op. Okay.
who's in charge of PR there. She's awesome, and she's like, "Do you want to meet him?" I'm like, "Yeah, I want to meet him." And then I'm like, "Hi, I'm Chris."
Right.
I don't know.
Okay.
I can't afford your 100 gigahertz scope. I mean, like, I don't know. It's like, yeah, that's great. Like, but I would have said the same thing to Joe Keithley if I would have met. I met Joe Keithley's son, but what do you say?
Yeah, okay. Fair call. All right.
Yeah. I did meet Eric Bogatin, and hopefully he'll be on the show in the future. So
okay. Nice.
That'll be fun.
I'm just saying you could have gone the extra mile there. That's all I'm saying.
Oh, right. Yes, let's look at the guest booking scoreboard here, folks.
Rub it in.
Dave's good friend Doug Ford still hasn't been asked on the show. Let's see. Chris does all the booking for everything. I think we're So
All right,
I think the issue is closed. Next week on the show,
Touche.
we will have Mark and Joe from Salier. So Salier they actually had to put it off 2 weeks because they wrote that interesting letter about the manufacturing, but they're going to come on and talk about it, which is great because we're really interested in that. They basically jumped into manufacturing on site and they've been fighting through that, and that's good. I finally got a Logic 4, so I'll have tried that out by then too. Right. So. And I know you've got one, so
I've got one of the old ones, yeah.
Oh, okay, yeah, I got the one with the analog on it, so
yeah.
Cool.
Right. That's it.
Good.
It's a wrap.
Talk to you next week.
See ya.
Good luck with your car.